when you got oil and water, everybody knows that oil and water don't mix, except they do. They form emulsions. So what happens is, if you have free oil, it flows to the surface and you can skim it off, and it's pretty easy. If you've got an emulsion, what you've done is broken a bond in this hydrocarbon chain, and this thing can be huge. But you'll have a positive and a negative there. And so if you have the negative, then what happens is it connects itself with the positive polar end of the water with this pseudo covalent bond that holds the water in there and just or the oil in there and just dangles it in the water like a yo-yo. Won't let it go. It's got a string on it. Same thing up here, except you got the negative end of the water to the positive broken bond. Okay, and that makes that nasty milky emulsion stuff that doesn't separate. So what we're doing here is we have our electrodes in here, and we put that water in, and so our oil, our free oil, goes up to the top up here and goes off over our waterfall real easily. If we have this emulsified oil and we have a positive open end here, because we have electrons in here traveling, and because we're putting an electric current through there, this electron goes up here and completes this charge, makes it neutral. So now we have a free oil molecule again, off it goes up over the top. If we have this negative charge here, because we have the...
If you change the charge on the emulsion, it will automatically separate.
Yeah, basically, yeah. It's called theta potential. Okay. And so if we have this negative charge up here, because we have electrolysis of the water that's going in there, because we're putting an electric current through water, we have hydrogen and oxygen atoms, atoms that are being split apart. So this hydrogen then comes up here and it attaches itself to that negative deal. Once again, makes it a completed hydrocarbon. Free oil and water don't mix. It flows over the top. The suspended solids that come in there are the silt and, you know, who knows what. Them guys typically have a positive charge in the center and a negative aura around the outside. And so they once again will hook up with this water molecule and dangle those suspended particles in there. So that's why things stay muddy for long periods of time, because of this charge. Once again, because we're putting electrons in here, we have a lot of electrons here. It floods the outside of this thing with electrons. This particle becomes very electronegative, okay? Because we have a aluminum splitting off of here, because the electrodes are sacrificial, we have an aluminum ion that is split off of there that has no anion with it, so it's very highly positively charged. It will collect a whole bunch of these things all around it and make that flock that you saw inside of there. If we have a metal coming in here, let's say we have dissolved copper coming in here, and it's dissolved in the water, you can't see it, it's on a atomic level, okay. So it will go in there because we have this electrolysis of the water. We'll have an oxygen in there, so it will make a copper oxide crystal. And that's what you saw, those big flakes
That's what
dropping
goes
out.
down the bottom. That's the coffee filter substance.
Well, you know, actually that's sluice stuff. Coffee filters for this sludge. See, and ideally we want to get all this metal out of there before we have the sludge, because the sludge is just dirt.
Right.
If we have this metal in there, then there's always a chance that it could leach out, although that's not very
Very probable.
likely to happen.